Manufacturing engineering has helped the world create many marvels, but this is a science that has its roots in the history of many countries. So today I, Aditya Asim Sarkar, will show how basic manufacturing engineering has shaped ancient India. The major topics that I will be covering are pottery, material science and metalworking, and metal casting. Pottery. Pottery is a primitive technical development of man. We may say that a potter is the first engineer and the potter wheel is the first machine. These days, we may even compare it to a lathe machine, as a basic shaping operation takes place in both. The Vedas compared the potter to the Creator himself. Pots were made of black or red clay and were burned in special kilns of different shapes and structures to give specific shades for an attractive fashion. Many chemicals were used, such as copper oxide for blue shades, iron oxide for bluish-green shades, and manganese for dark maroon shades. The complicated and geometrical shapes of pots throw light on the Harappan potter's skill and technical soundness. Indus Valley civilization is also famous for its burnt bricks with specific dimensions. These bricks were made of clay, silica, limestone. There, it has been observed that they have a steadiness in their dimensions. These bricks were made using wooden molds, so it is needless to say that Indians did master pottery before the Egyptians. The composition of clay that was used in the Vedic age was 40% aluminum oxide, 46% silicon oxide, and 14% water. This is the photograph of a bonfire kiln. Usually, a hole was dug in the ground and hot charcoal was placed in it. The moist clay pots were then kept inside and covered with dry broken pots and ash. The trapped heat dried the pots, but the main disadvantage was that even drying of pots did not occur. To solve the problem of bonfire kilns, downdraught and updraught kilns were used. This is a downdraught kiln. The fire burned at location marked 1, and the dome marked by 2 was a temporary structure. The pots were first kept inside, and then the dome was made by mud and bricks. After the pots dried, the dome was broken and the pots were taken out. The exhaust went from position 1 to 2, and then it went down to the hole connecting to the chimney. So it was called a downdraught kiln. This is an updraught kiln. It is very similar to a downdraught kiln in shape and structure, but the only difference was that the path of the exhaust was from bottom to top. There have been many discoveries that show how skilled the Vedic age potters were. The first one is a Indus Valley civilization pot from the Harappan phase found at Quetta, Balochistan, dating nearly 2500 to 1900 BCE. The second one are clay pots from Punjab region. In this slide, the first picture is of black and red ware cooking utensils from Sonk, Uttar Pradesh. Currently, they are at the Government Museum in Mathura. The second picture is of a storage jar from mature Harappan period at the National Museum, New Delhi. It is dating nearly 2700 to 2000 BC. The first picture is of a traditional potter's wheel. Many such potter's wheel have been found at various excavation sites. The second picture is of the Indus Valley civilization burnt bricks. Material science and metalworking. Indians were well versed in material science and metalworking. They knew about rusting, corrosion, and also about its prevention. Ancient Indians were very skilled in metalworking and had knowledge about material behaviors like tension, deformation, and compression. Forging was the earliest metalworking technology. Agricultural and military equipments were made by forging. Many tools such as anvils, hammers, tongs, and chisels have been found at various excavation sites. Evidence of practices like temperature recrystallization, cold working, and work hardening have been found by metallographic examination of various samples. Plastic deformation, annealing, grain growth, twinning of grains, have also been identified in many samples. Other forms of metalworking like drilling, drawing, polishing were also practiced and mostly by the jewelers of ancient times. The clothes were made of gold threads and ancient artisans have shown great skill in gold coin making. Small beads have been found with diameter of 1 by 34 inch. This enlightens the fact that Indians were skilled in carving, shaping, drilling and boring operations. These beads were drilled so that 30 to 40 such beads would make a necklace. It is difficult to imagine the handling devices that held the beads while drilling took place. Indus Valley Civilization people used magnifying glasses made of polished gems and delicate saws to cut the beads. Deep pots and pans were made by sinking technique. Cups and basins were made by raising technique. These are some related discoveries. These holes were made using complex machines rather than hammer and chisel. The second picture is of the various jewelries that were discovered from excavation sites. These jewelries contain necklaces made of 1 by 34 inch diameter beads. These are ancient anvils that were found at various excavation sites. We can see that these anvils were very much similar to our modern day anvils. The second picture depicts how forging was done during the Vedic age. It was done initially by heating the metal in a pit of coal, and then the metal was beaten using hammers to get the required shape. These are ancient hammers and chisels that were found at various ruins. These hammers and chisels were the only instruments that were used to make the Ajanta and Ellora caves, all the 34 caves. This is a wheatstone rock. It was used to sharpen blades like swords and axes or anything that was taken to battle. These are the various tools such as tongs, files, saws, etc. that were used during the Vedic times. These tools have been excavated from various excavation sites. During the Vedic age, holes were drilled by wounding a rope around the drill and then pulling it alternately from both directions. This is a Harappan seal that was done using hammer and chisel. This is an ancient gold coin of the modern age. We can see the detailed design on such a small coin. This throws light on how skilled the coin makers were. These are various Indian blades that were created by forging. Not only Indians but Romans created their battle armors using steel that was imported from India. After Alexander acknowledged the high quality of the steel during his battle with Porus. Metal casting. Casting is one of the oldest of all production techniques. It evolved in ancient India and its development can be traced to the early Vedic times. Various equipments were used, namely the dhamatri or cupola, the bhastri or the blower, the titau or the sieves, the trays, the gharma iron maya or the crucible, and core boxes. Axes, plows, various domestic implements were made using casting method. Casting was similar to our modern day investment casting. Bee wax was used to make the patterns. Then the molding sand, that was a mixture of clay, sand, charcoal, husk, gingli oil and salt, was pasted on it. By external heating of mold, the wax was melted and taken out through a hole and pouring basin already in the mold. Molten metal was then poured in it. This method is most ideal for getting intricate, dimensioned, complex, smooth, and defectless casting. Ancient Indians were proficient in core making and used different core boxes. Cores were made of a special foundry sand that was a mixture of clay, sand, charcoal, gingli oil, and cow dung. Evidence of different molding techniques have also been found. These molding techniques included open cast mold, closed mold, and double mold. Patterns were not only made using wax, but also wooden, clay, iron, and steel patterns were also used. Their furnaces resembles a lot like our modern day cupola furnace. The materials that were used in casting were gold, silver, copper, bronze, and iron. These are the various equipments or materials that were used during casting in Vedic age. At the top left corner we have the bee wax that was used to make the pattern. At the top right corner we have the old crucibles that have been found at many excavation sites. At the center we have the sieves that were to used in filtering the sand. At the bottom left corner we have a depiction of the Vedic age foundries, and these foundries were mostly made using clay and bricks. At the bottom right corner we have the blower that was used to supply oxygen to the burning coal. These are some related discoveries. This is the iron pillar of Qutub Minar. Till date, this pillar has not yet rusted, and many say it is because of the content of phosphorus in the pillar. But the exact method of casting, or why the pillar is not rusting, has not yet been specified. These are the famous Nataraj figures of South India that were made by casting. This is the Jaivana cannon. It is the largest ancient age cannon of India and was completely made by casting. A similar cannon, the Malik-e-Maidan cannon that was used for the security of Buland Darwaza, was also made by casting. I would conclude by saying that the Vedas are the principal source of knowledge and form the basis of many of the scientific principles that have been outlined. Since the subject of Vedas is of enormous dimension, only those aspects having impacts on the material science base are mentioned that have significance for further thoughts. The scientific aspects of Vedas have already been attracting attention worldwide, and it is hoped that the future rests on development of mankind along the righteous ways which the modern science strives for and the Vedas stand for. Thank you. If there are any questions, please feel free to use the comment box.